When we talk about high availability, there are two concepts. One is load balancing and the other one is failover. We just got done talking about load balancing, where the primary focus was having many different servers running at the same time to split the load of the traffic. There are many services that we offer that we simply couldn't do it on a single server because there's no single server that would have the power to handle all that traffic. But the other reason is because we want to have more than one single point. We don't want to have that single point of failure. If that server goes down for any particular reason, whether it's regular routine maintenance or because there's a hardware failure or a software failure, then all of those services go offline. So that was the primary goal with network load balancing. With failover, the idea is that we want to make sure that we might have the ability to offer the services on the servers that we have, but we want to fail over if there's a failure on the primary server. So usually with failover, we're talking about when a server goes offline, another server takes over. However, the line is pretty blurry between these two. I used the example of a 747 earlier that has 4 engines, and they have 4 engines because for optimal performance, we use all 4 engines on a 747. But can it fly with just one engine? Yes. Is it a good idea? Not really, right? You probably wouldn't feel too safe flying on a 747 with a single engine. It'll probably get you where you want to go, or at least close to where you want to go, and it won't fall out of the sky, but it's not the most efficient way to operate the airplane. Same thing with our IT infrastructure. We can probably operate on a single server in a cluster, but it's not the best way to operate. So a failover cluster is all about just keeping things online through significant failure. But like I said, the line is blurry because really both scenarios give us the same thing, right? The only difference is with failover clustering, we're not worried about load balancing, which to me is very rare that we're not doing that. Usually we want to make sure that we're using clustering for load balancing, and a nice side effect is that we have failover because if we lose servers, we're still online. In fact, when I spec out servers for various services, I always make sure that my cluster works even through a 50% failure. So what I'm doing when I design systems is I'm saying we're going to run the cluster with enough capacity to handle a certain percentage of where each server could handle a certain percentage of the traffic, but the aggregate should be more than I need. That way, if I lose a certain percentage of my servers, if they go down for maintenance or for unplanned or unscheduled downtime or something like that, we're still online. So that's the basic idea. So let's go ahead and talk about failover clustering, which isn't all that different, again, from network load balancing. Um, so it's deployed for high availability. Data and applications are almost always available even after a system failure, and it's good for mission critical applications. So the terms used to describe failover clusters, you have cluster application, which is an application or service installed on 2 or more servers participating in the failover. Cluster server, which is one of our servers that has the services installed. The active node is a cluster member responding to client requests for network application or service. A passive mode is one that is not actively responding to those requests, but it is in standby to do so if the active node goes down. So the passive node is that sort of waiting to answer the call to service. And standby mode is a cluster node that is not active. So really, standby mode and passive mode are roughly the same idea. And a quorum is a database containing cluster configuration information about the status of each node in the cluster quorum. And a witness disk is the shared storage used to store cluster configuration data and help determine the cluster quorum. So in other words, it's a shared disk that all the servers can use. So the problem with servers going down is if you're storing any information on a server that goes down, then it won't be available anymore, right? So the idea is that you have a shared disk, which is the witness disk and the quorum database. These are shared amongst all of the servers in real time by using a separate device, which is typically a SAN, so that a sudden failure on the primary node does not affect the backup node's ability to take over, because it's going to know everything that server knew when it went offline. So a failover cluster consists of 2 or more servers, usually of identical configuration, as I said before. And just like before, when I talked about, and by the way, storage usually have to have a SAN for external storage that can be shared among all the servers. And you can assign clusters so that each server is active to a particular application or service, or in standby mode for services, etc., etc. But just like I said before, this is also something that can get done with an appliance outside of the Microsoft Windows realm. So as far as, let's say you design or you developed an application that you want to do failover clustering, as long as they share the same database, and if they're sharing the same storage, then putting a network load balancer in front of them to do to divert that traffic achieves really the same goal. So, and it's a lot less complicated to configure it because you don't have all the complexity with Microsoft Windows in how it does clustering, which you're going to see in the next 30 slides here. So again, you can do this with an appliance as well. So it's important to keep that in mind. This is not the only option. So basically the way that the failover cluster works is the client computers can see the failover cluster as a single entity, just like we did with network load balancing. So they have a single virtual IP address and a single FQDN to access them. They all have access to the application data, so that if any active server fails, the other can take over, which I just talked about. So that's typically facilitated through a SAN. And passive servers will know when the active server is no longer able to serve by using a process called a QUORUM, which is how it determines if all of the servers are online. So a consensus among cluster elements about the cluster's status is the QUORUM, right? So the QUORUM is the consensus of exactly how things are working. So there's a variety of QUORUM models. You have the node majority QUORUM used for clusters that have an odd number of members. And then you have the node and disk majority QUORUM, which is used by clusters that have an even number of clustered nodes, and node and file majority QUORUM, which is uses a file share rather than a shared storage to store the QUORUM data. So a file share is different than shared storage in that a shared storage is where we all mount the same iSCSI drive on a SAN, right? So we're all managing that same storage device, whereas a file share is more or less file sharing, right? So that's a file sharing level thing. So has to be an extra server managing that file share, although in most cases we have a file server laying around that we could do that with, but that's basically how that works. And then in node majority is a disk-only QUORUM, which allows the cluster to remain operational as long as the witness disk is available for at least one server. So all cluster servers have to have 2012 R2 standard or data center, just like with network load balancing. They have to have identical or nearly identical server components, identical CPU architecture. The components should meet the certified for Windows logo requirements, although it's not required, but they should. Separate adapters for shared storage communication and network client communication, similar to the network load balancing discussion we had previously. So the supported cluster compatible storage technology, such as a SAS, fiber channel, or iSCSI. We talked about iSCSI already. In the previous course, we talked about SAS and fiber channel. In my experience, iSCSI is the easiest to set up for this, but for iSCSI, you're going to use network adapters that's dedicated to cluster storage. Obviously, you don't need that if using fiber channel or SAS because they don't use Ethernet. They use their own transport mechanism. So you have to have a minimum of 2 volumes, one of which the server uses as the witness disks for the cluster. All right, they have to have the same edition of Windows Server 2012, which I talked about before, and all of the applications have to be on the same version. And by the way, this is only supported with Microsoft applications, which is another limitation with using Microsoft for failover is it only works with Microsoft services for the most part. Although I've heard people have been able to do some things using other services, but a good example is Microsoft SQL Server works with clustering like this. But the odd thing is Microsoft SQL Server has its own clustering mechanisms as well that work outside the scope of using clustering in the operating system as we're describing here. So even Microsoft doesn't seem to have 100% confidence in their own product here. So the cluster application's data must be available to all cluster members. Shared storage is required on clusters using disk majority and node majority, which are disk-only QUORUM models. And all components of the storage system should be Windows Server 2012 certified, which we mentioned before. This is mentioned several times in your textbook, but in this part of the book, they talk about how it should be digitally signed device drivers. I don't believe that this is required, but obviously, it's a good idea. Like I said, these setting up clusters with Microsoft Windows is a little like burning a CD-ROM in 1996. You start the process and you kind of back slowly away from the computer. Don't touch it once it's running. Or doing plumbing on a drain where you kind of get everything just the right way and hope it doesn't leak. So for failover cluster installation, the procedure for installing and creating a failover cluster is as follows. You're going to install the failover clustering feature on all of the servers. Then you're going to verify the cluster server network and shared storage access. Then you're going to run the cluster validation wizard and finally create the cluster. So, excuse me. So you can perform this step before installing the failover cluster feature. This is verifying the storage, that is. So you can make sure that the storage is working, that you're able to create files, because this is going to be a requirement to move on to the next step. All right, so you're going to verify all the servers can communicate with computers on the client network. So, all basic stuff we would do anyway, right? Make sure the shared storage is visible in disk management. Then we're going to run the cluster validation wizard. So before creating a new cluster, you're going to run this validation wizard on the failover cluster manager. So it's FCM is added as administrative tools after you install failover clustering feature in Windows. So you'll have this in your tools menu. And if you go in the server manager, click tools, it'll be in that list. So in the second window of the wizard, you're going to be prompted to enter the names of the servers that are going to participate in the cluster. And you're going to choose the testing options that you want to use, and you should run all the tests when validating a cluster for the first time. And this is what the dialog box looks like in the cluster manager. So then you're going to create the cluster. So after we validate that the cluster, everything's set up correctly, then we're going to start creating the cluster. So during this process, you're going to be asked to enter a name of the cluster in the access point for administrating the cluster window, and you're going to enter an IP address for your cluster. So the name and IP address are going to get added to DNS, and then a new computer object is created in Active Directory with the name of the cluster, and the IP address is assigned to the network adapter selected for handling cluster clients. And I should mention here in my experience that clustering failover clusters with Microsoft Windows generally work okay with Active Directory, but if you're not using Active Directory, then this can be significantly more complicated and less reliable. So configuring a failover clustering, after the cluster is created, you're going to have to perform some additional tasks. You're going to be configuring the cluster networks, configuring the QUORUM model, the storage, to configure your cluster role. So let's talk about the cluster network. So the cluster networks are going to be used for client access, communication within the cluster, and for the storage network. So you should have at least 2 separate networks. 3 is best, but you have to have at least 2. I've seen this done with 2, and it seems to work okay. Each network adapter should be connected to a different subnet and should be renamed to reflect the network function. In other words, that way you remember which one is for which, right? So you can rename the network adapter and say it's for client access or for cluster communication. And this is, of course, where you would do that. So in the failover cluster manager, to configure the QUORUM model, you're going to click the name of the cluster in the left pane, and in the actions pane, you're going to go to more options, and then click configure custom QUORUM settings. So the configure cluster QUORUM wizard is going to walk you through changing the model. So you've got a couple different options. You can use the default QUORUM configuration. You can select the QUORUM witness, the advanced QUORUM configuration. Okay. So during the cluster creation, Windows detects shared storage and assigns one of the cluster nodes as the owner. So by default, each cluster disk is owned by one cluster node. All other cluster nodes see the disk as offline. You can configure a cluster shared volume, which is a CSV. So all cluster nodes have access to the shared storage for read and write access. So to create a clustered shared volume, you're going to click the disks in the left pane in the failover cluster manager, right-click a disk assigned to available storage, and then click Add to Cluster Shared Volumes. So after it's been added, it appears as in disk management as a CSVS, or Cluster Shared Volume File System. So the advantage of using a CSV is that you have better backup and restore functions, support for BitLocker or volume encryption, improved performance. You can use SMB 3.0 for file sharing, support for multiple subnets, REFS formatted volumes. So we talked about that in the previous course, but REFS is sort of a file system. It's like NTFS. It is a Windows file system, but it supports much larger disks. Among other things, much larger disks, a little more efficient for huge data stores, and also data duplication, as well as support for tiered and parity storage spaces. So using a CSV does give us quite a few advantages, and I don't believe I've ever seen anyone set up a cluster without using CSVs. I think the few times I've done it, it seems like we have to do it that way. So to configure a cluster role, to configure a server role to use failover clustering, you're going to right-click on roles in the left pane, and then you're going to click Configure Role to start the High Availability Wizard. And then before you run the high availability wizard, you must install the role or feature on each server in the cluster. So they all have to have this installed in order to configure it. And this is what it looks like. So cluster-aware updating is going to automate software updates on the cluster servers and maintains the cluster server availability. As I mentioned before, everything has to be on the same versions in order for clustering to work. So, so you're going to have to see, if you run Windows Update on one of the cluster nodes, or it automatically runs, it's going to ruin your day. So you have to use cluster-aware updating in order to ensure that this is not going to take down the cluster when you do Windows updates. So to enable CAU, you're going to right-click on the cluster in the Failover Cluster Manager, go to More Actions, and then click Cluster-Aware Updating. And then it should be able to do Windows updates for you, and this is what it's going to look like. All right, and that concludes the unit on network load balancing and failover clustering. As I said, this is it's available in Microsoft Windows Server. It's certainly an important part of Windows Server, but I don't see this used that often because a lot of folks tend to gravitate towards using third-party solutions that that certainly simplify this configuration a bit. Usually using an appliance like Barracuda or Cisco or F5 or something along those lines. So in my industry experience, I see far more people using those solutions than using this natively in Windows. But it's certainly a capability and a feature in Windows, and certainly something you could take advantage of. And that concludes this slide deck. There is another slide deck in this unit, so be sure to watch the remaining videos. We're going to talk about high availability using virtualization.